Hi children. Hi. Today we discuss the nature and position of the images formed in case of convex mirror. Earlier we studied concave mirror. Concave mirror able to form the image in 6 positions. So when object is placed at 6 different places, object is at infinity, image will be at focus, and object is between infinity and center of curvature, the image will be between center of curvature and principal focus. As the object is moved and kept at center of curvature, image is again formed at the center of curvature. Fourth case, when object is kept between center of curvature and focus, image is formed beyond center of curvature. And when object is kept at within between center of curvature, between principal focus and the mirror, image is formed, that is on the other side of the mirror. In that case, the concave mirror able to form the virtual straight magnified image. So a concave mirror can form a virtual straight magnified mirror only in one case, that is when object is placed between principal focus and the mirror. In all other cases, it is said to be a convergent mirror. That means the reflecting rays are going to converge at one point. All convergent rays always forms real images. All real images are always inverted in nature. They may be diminished or they may be magnified. The distance of the object is more than radius of curvature, it is a diminished image. When the distance of the object is equal to radius of curvature, so size of the image is same as that of the size of the object. If the distance of the object is less than radius of curvature, then magnification occurs. That is, size of the image will be more than size of the object. But in case of convex mirror can never magnify the image. Convex mirror always forms virtual images. All virtual images are always straight images. Say for example, the mirror that we have for a car on the right side is a convex mirror only. So we are able to see a straight image in the convex mirror with a field of view, right? So now children, I explain you the two cases which we come across in case of convex mirror. Please carefully observe and understand. If the doubts are there, please raise your hands. I will clarify this. Let us draw the convex mirror diagram first of all. The polished surface is toward the center of curvature. See now, this is a polished surface. The polished surface is towards the center of curvature. This is a section of the mirror XY. The section of the mirror XY, whose center will be on the right side only, that is towards the polished surface. So this could be the center of curvature. And this is the midpoint of the given section of the mirror, pole. The pole always lies on the surface of the mirror, but center of curvature lies at a distance from the pole of the mirror. That's why now we can join these 2 points forming a principal axis. This is called a principal axis. Principal axis. This is center of curvature. So definitely there will be a focus. The focus will be the midpoint of what? PC. This is the focus. Now object must be placed in front of the mirror. So in front of this is nothing but unpolished surface. A mirror is placed always, an object is placed in front of the mirror. Say now the object is suppose kept at infinite distance. The rays which are coming are parallel to each other. These are the parallel rays, and near the principal axis, we are showing it like this, but the rays which are proceeding from such an object are near. They are near the principal axis, hence they are also called paraxial rays. This is an incident light ray. This is incident light ray. Another ray you can imagine in this direction also. And this makes a normal incidence so that it is reflected back like this. And this ray is incident at certain angle on the surface of the mirror like this. So therefore, it is now reflecting. It is now reflecting like this. You see, it is reflecting. This is diverging like this. It is diverging. And another ray is now you can see this is also, you just keep this till it touches the focus, and then from there you better draw divergent ray like this. And if you extend this line, it has to pass through focus because incident rays are parallel to each other. Therefore, the divergent rays appear to be diverging from this point. They appear to be diverging from this point, so you should connect this with a dotted line now. This is the dotted line. So this you have to connect with what? A dotted line. It's like this. It is dotted line. It is dotted line like this. So children, now the image is said to be formed at focus. This is image. It is a virtual image formed at the focus at a distance equals to focal length. It is formed at a distance equals to focal length. So this is A, this is B. So this is M, this is AN. AM, BN. These two rays are parallel. These two parallel rays, after the incident on the mirror, a part of light is absorbed and the most of the light is now diverging. These two divergent rays, when they pass through our eyes, and we feel as if the rays are coming from this principal focus. So image is said to be formed at the principal focus. This way we are going to construct the image. This is a highly diminished point straight image. So now children, you see the case we can write like this. When object is placed, when object is at infinity, before a concave mirror, this is what? Convex, not concave. Convex, this is mirror, convex mirror. A virtual, straight or erect, a virtual, straight, highly diminished image, diminished, D-E-M-I-N-I-S-H-E-D, diminished image is formed at its focus, at its virtual focus, F. So when object is at infinity before a convex mirror, a virtual, straight, highly diminished image is formed at its virtual focus as shown. So here distance of the object is infinity, Nana. Distance of the image is how much? Tell me at what distance the image is formed. At the focal length of the mirror is f. Then we have the formula 1 by f equals to 1 by v plus 1 by u. This is a mirror formula, reflection formula. Hence 1 by f equals to what? This implies 1 by f equals to 1 by v plus 1 by infinity. 1 by infinity is 0, which implies v must be equals to what? V must be equals to what? U. V must be equals to what? V must be equals to not u, sorry. V must be equals to what? F. Because 1 by infinity is 0. 1 by v equals to 1 by f. V must be equals to what? F. Very good. Please note down. Next case. Case number 2. This is case 1. Case 2. In second case, wherever you place the object between the mirror and infinity, wherever we place the object between the mirror and infinity, the image must form within the focus. Please remember, within the focus. That means as the distance of the object is decreased, the distance of the image also decreases, but the size of the image increases. As the distance of the image is increased, that is decreased, and the distance of object is decreased, the distance of image also decreases. The size of the image by size of the object equals to distance of the image by distance of the object. That is called magnification. Therefore, you can see the image magnifies slowly. It is going to magnify. Fine. Now we can write the diagram for that. Please see here. This is the section of the mirror, XY. And you just take this as what? Polished surface. The midpoint of the given section of the mirror is called pole, and this could be the center of curvature. And the line passing through the pole to the center of curvature is called principal axis. This is called principal axis. Now this is called principal axis. So I should show principal axis. Principal axis. Now the object can be placed anywhere in between the mirror. So suppose somewhere I kept here. So this is the size of the object. It is kept here now. This is subject, object size is O, that is B. Let us take it as OB, and let us construct the image that is so formed. Whenever an object is placed before the mirror, the image can be formed. To construct an image, see, always three rules I have told you. The first rule is, when the incident ray is parallel to the principal axis, the reflecting ray must pass through the principal focus or appear to be passing through principal focus. See, now this is an incident light ray, say for example. This ray is parallel to the principal axis. So it has to pass through principal focus, or it appears to pass through principal focus. But this is it is a convex mirror. Convex mirror is a divergent mirror. Divergent mirror means, so it is diverging like this. So this divergent place appear to be diverging from where? Principal focus. It appears to be diverging from principal focus. That means appears to diverging from the virtual principal focus. The ray which is parallel to the principal axis appears to be diverging from principal. We feel as if the ray is diverging from point F but not from point B. So another ray I am considering now. Any ray that is incident on this mirror at an angle 90 degrees must travel through center of curvature. So just keep the scale like this. Center of curvature is here. See, now this is center of curvature. See, now this is center of curvature. This is the position of the object. Now we feel this is, so how it is coming now, you see. This is another incident light ray. It is incident here. It is incident here. So that it makes what angle with the surface of the mirror? That is 90 degrees. Therefore it retraces its path. It retraces its path means it is now going like this. It is retracing its path means it is going like this. You see, this is the direction. Like this it is going to. So it is incident here and retracing its path. But we feel as if the ray is diverging from which point? See, center of curvature. So center of curvature, till center of curvature we extend it with what? Dotted lines. Like this, dotted lines. It should be extended with what? Dotted lines. Like this, it is extended with the dotted lines. So we feel as if the ray is diverging from center of curvature. Now where these two are converging? That two rays are converging at this point. Therefore the image is said to be formed there only. This could be the image. That is the image. Here this is the image. Earlier it was image. Now this is the image. Image is formed within the focus. This is focus. Within the focus. Image. This is an image formed. IM is the image. IM is the size of the image. Image. Size. Image size. OB is object size. Object size. So now this is the case. I explain you once again. This is an incident ray. The incident ray is parallel to the principal axis. So it appears to be diverging from principal focus. So another incident ray is proceeding from the object, because we need two incident rays to form the image. So second ray is incident on the mirror at an angle of what? 90 degrees. So exactly it makes an angle of 90 degrees here. That's why it retraces its path. But we feel as if the ray is retraced from the point C. It is coming from point C. So and these two reflecting rays now converging at this point. This is called point of convergence, virtual convergence. It is not real convergence. Point of virtual convergence. So if you imagine a normal to the principal axis, that gives the value of what? That gives the size of the image. The image can be formed at this point. See, children, this is a case. So we can understand like this. Now the object is kept on the left side and image is kept on the image is formed on the right side. Now the distance of the image will be less than focal length. Here distance of the image is equals to focal length. Here distance of the image is what? Less than focal length. This is the distance of the image. So therefore distance of the image is decreased as the distance of the object is also decreased. U is, this is the distance of the object. Here the U value is infinity. Here the distance of the object is what? Infinity. It is now decreased from infinity to a finite distance. From infinite distance to a finite distance. So that the distance of the image is now decreased from, this is finite to what? And indefinite. That means within the means it is now the distance of the image from the pole of the mirror is now taken as what? B. So distance of the image is decreased as the distance of the object also decreases. So now you can see the more size of image than what the previous case. That means the magnification is increasing, but the magnification is always less than 1 in the case of what? This the convex mirror. This is called a convex mirror. So this is the case. I think you understood it. Now let me write the sentence there. Children, see the case number 2. When the object is kept at a finite distance before the mirror, a virtual straight magnified image, a virtual straight diminished image, a virtual straight diminished image is formed within the principal focus of the mirror. On the other side means polished side of the mirror. So these are the two cases. Wherever we place the object between infinity and what? This mirror, that final image should be within the focus, that is between focus and pole, between the focus and. So convex mirror will never magnify the image. So the magnified, it can never magnify, but the advantage with this mirror is it can form a straight image. Straight images can be seen through the mirror. So that is the importance of this mirror. Please it have. One more thing regarding sign convention. So we have to adopt the sign convention part. Of course, we will discuss it separately. Any distance that is measured opposite to the incident light. Incident light is coming from left to right. Any distance that is measured, all the distances must be measured from pole of the mirror. That is the first one. First sign convention. Pole of the mirror. Any distance, if you want to measure the distance of the object, distance of the image, whatever it is, or focal length, so you have to measure it what? From the pole of the mirror. So the condition is what? Coordinate axis sign convention it is called. So this is any distance that is measured that is against the incident light. So distance of the object is kept at infinity, that has to be measured from pole. So you are measuring it from pole, so you are moving that is against the incident light, therefore the distance of the object will be negative. And the image distance is measured in the direction of incident light, so the distance of the image will be positive. Focal length also is this side, so focal length is this side, therefore the focal length is said to be positive. Please, coordinate axis convention everyone has to remember. We will discuss it separately also. Now distance measured opposite to the incident light is negative. Any distance that is measured in the direction of incident light is positive. So in the convex mirror you can write distance of the object is what? Negative. Distance of the image is what? Positive. Focal length is what? Positive. Radius of curvature is what? Positive. Because radius of curvature is always equals to what? Twice the focal length. Radius of curvature is always equals to twice the focal length. That can also be proved easily. Thank you. I think you are noting down. Not down, please. Thank you.